Do a quick summary-ish on how to name nomenclature. So if I'm given a chemical formula, what rules do I apply to name stuff? Well, it's all based off of what the first element is. Sometimes it might be a polyatomic ion, but usually it's an element. If the element is an H, so first element. If the first element is an H, then I apply the rules of acid nomenclature. I like to say if it starts with H, it ends with acid. What are the rules for acid nomenclature? Well, we'll get back to that after we break out what these other things are. Another choice, if it's not an H, then is it a non-metal? What's a non-metal, you say? Well, a nonmetal is anything that's to the right of the metalloid. So this is our dividing line for the metalloids. Anything to the right of that is a nonmetal. So if it's a nonmetal, then we use the rules that are for covalent nomenclature, which means we're going to use prefixes. And again, in a bit, I will go through all of those. Our next choice is if the first thing is a metal. A metal, you say, what's a metal? Well, metal is anything to the left of the metalloids except for hydrogen. Hydrogen's a nonmetal, but every other thing here is a metal. Now, if it's a metal, that means we're going to follow the rules for ionic nomenclature. And now there's two different types of ionic. There's what I like to call normal, I can spell, normal metals, and then there are special metals. What is the difference between a normal and a special metal? Well, it's whether or not we know the charge of it. So for our normal metals, it's anything in the alkali metals, the alkaline earth metals, and this aluminum column here. Remember, boron's not a metal, it starts with aluminum. So if you notice, and on our periodic tables that we have in class, we use ones that have the charges on top. So anything that's in a column with a charge, and it's going to be a positive charge on top, is a normal metal. And so those rules are going to be different from our special metals. So if the normal metals are the ones with the charges on top, then our special metals are these ones here in the D block, the transition elements, and also here the metals, tin and lead. In column 4, hey, you'll notice there's no charge here. So I like to say that the special metals are the ones without a charge on top of the column. So those are the D block. So those are the ones that have the B's. You can see they have the B's with the numbers on top, and also column 4A. Those are our tin and lead. So when we do those, these are the ones that need the Roman numeral. Okay, so those are the different categories. So now I'm going to go through what the rules for each of these are. So acid nomenclature, if it starts with H, it ends with acid, but there's two different types of acid. There's H plus another element. So like HCl or H2S or H3N or, something like that. That's what I mean, hydrogen with another element. When we do those, we're going to use hydro blank ic acid. So this would be hydrochlor, right? This is chlorine. So we'd put chloric acid here. This is sulfur. So that would be sulfuric acid. So it's hydro blank ic acid. So we use hydro when it's H plus an element. If it's H plus a polyatomic ion, so like HClO3 or HClO2, right? These are polyatomic ions. And when it's H with polyatomic ions, there is no hydro. You just write the polyatomic ion, and then it is either ic acid, or it's the polyatomic ion and it's aus acid. So no hydro. So how do you know if it's ic or if it's aus? So if it's a polyatomic ion that ends with ate, it becomes ic. And if it ends with ite, it becomes aus. So for example, if I have this here, H with a polyatomic ion, so if it starts with H, it ends with acid, this is chlorate. So I'm going to chop off the 8 and I'm going to make this chloric acid. So no hydro, polyatomic ion, just change the ending. If it's 8, it becomes ic acid. If it's ite, it becomes aus acid. So those are the rules for acid nomenclature. Starts with H, it ends with acid. Now, prefixes, right? The prefix, so if it starts with a nonmetal, then we have these prefixes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Those are the prefixes. The prefixes tell me how many there are. So you use the prefixes to indicate the number of atoms. But you don't use a prefix if there is only one of the first element. So what do I mean by that? Well, what about CO2? Carbon, I find it on the periodic table. I see that it's a nonmetal, so that means I'm going to use prefixes, but there's only one carbon, so I don't use a prefix here. When we name them, you're going to name the first element. Do not change its name. This is carbon, so we write carbon. You name the second, and we change the ending to IDE. So, but we got to use our prefixes. Prefixes indicate how many. So this is 2, right? So 2 is di. So this is going to be di. This is oxygen. So we're going to change the ending to IDE, and that's oxide. Carbon dioxide. Or maybe we have N3 Cl7. We use a prefix now because there's more than one. So this would be tri, right? 3 is tri. That's nitrogen, so you just name it. Don't change it. Trinitrogen. 7 is hepta. So this is going to be heptachloride. So if the first one's a nonmetal, we're using the prefixes. Name the first one. It gets a prefix if there's more than one. Name the second one with the prefix to indicate how many, even if it's just one. And then change the ending to IDE. Okay, that's nonmetals. Now, if the first one is a metal, and it's a normal metal, then you name the first element, or it could be a polyatomic ion if it was ammonia. Name the second. If it is an element, change ending, oops, that's not how you spell ending, ending to IDE, just like you did down here. If the second thing is a polyatomic ion, then just just name it. So what do I mean by that? Well, what if I have NaCl? Well, first one, you just name the first element. That's sodium. Second one, you name it, but if it's an element, right, that's the element chlorine, you change the ending to IDE. So this is sodium chloride. Or maybe it is MgPO4, magnesium phosphate. We would just name it. Magnesium is the first one. This is the polyatomic ion phosphate, so we just name it phosphate. Easy peasy. So if it's the first one's a metal and it's in a column with a charge on top, just name it. If the second thing is an element, change the ending to IDE. Other than that, you don't change anything. All right, what about this weird Roman numeral thing? Well, we still follow this name the first thing, name the second thing. So this still applies. Name the first thing, name the second thing. If it's an element, change the ending to IDE. If it is a polyatomic ion, just name it. But we have to include the Roman numeral. So the Roman numeral indicates the charge on the metal. The metal's that first element. So for example, if I had copper with sulfur. So copper, here is copper. Notice it's in the transition. There's no charge on top. That means I have to use a Roman numeral. So I still follow this. I name the first thing. But I'm going to put parentheses in for a Roman numeral. This is the element sulfur, so we change the ending to IDE, so this is sulfide. Now I got to figure out what is the Roman numeral. So what we got to do is the Roman numeral is the charge on this first one. So this is sulfur, and if I go to the periodic table, I find that sulfur has a charge of -2. So sulfur is -2. There's only one of them, but I have 2 coppers. So if I do this, 2 times x minus 2 has to equal 0. So the number of the first element that I have times x minus how many of the second one I have, which is just 1, times its charge from the periodic table, which is -2, has to equal 0. So that means x has to equal 1. So this is going to be copper 1 sulfide. If you want more details about how to figure out the Roman numeral, I have a separate video that you can find in Canvas for calculating the Roman numeral. But basically, the Roman numeral is the charge on the first thing, and the charges here have to add to 0. All right. Hopefully that helps you with naming nomenclature.